Okay, so we'll be going through the dynamics tutorial too. So this tutorial is relatively simple. I'll split it into about 3 parts to 4 parts. So I'll be going through question 1 and 2 for this part. Now, the first question is, a baseball is thrown downwards from a 15-meter tower with an initial speed of 5 meters per second. Determine the speed at which it will hit the ground and the time of travel. So, with this question, we can tell that there is only one acceleration factor, and that's gravity. So with that, right, we can use the constant acceleration formula, which can be shown over here. This is also known as a no-time equation. So velocity final square is equals to velocity initial square plus 2 acceleration multiplied by the displacement. So we have the displacement, we have the initial velocity. I'll take downwards as positive, as the baseball will be traveling downwards and makes calculation a lot easier. So velocity final is the one that we do not know, but we have velocity initial, which is 5, so we put in 5 square plus 2 bracket the acceleration gravity will be 9.81. Since it's going downwards and I take down as a positive, so this will be positive. Same goes for velocity, because the velocity is going downwards, right? But I take downwards as positive, hence it becomes positive 5 over here. And the displacement of 15 meters is also positive, even though it's going downwards, because like I said, I've declared it as downwards as positive. With that, I can find what's my final velocity. Now they want us to find the time of travel. I have initial velocity, I have the final velocity, I just need to find the time, because acceleration is just gravity. Very simply, I can find time. Alright. For the next question, the motion of a particle is defined by the relation x equals to t to the power of 4 minus 12 t to the power of 2 minus 40, where x is expressed in meters and t in seconds. Determine the position, velocity, and acceleration when t is equal to 2. Now, with the position vector in the x direction, we can sub it into the position vector over here. So position vector has this general form where position vector is x in the I direction plus y in the j direction. In this case, they didn't give you what's y, but they tell you what's x. So you put whatever you have. So over here, I put x. I just pick this up over here, put it in here, and then y is 0. Then with that, I have the general position vector equation. I just sub t equals to 2 into this position vector, and then I can get my position, which is negative 72i. To find velocity, I just need to differentiate this position vector in terms of time. So I do the time derivative of this position vector, and this is what I will get, okay, which is over here. Likewise, I will just sub t equals to 2 into the equation and get my answer, and this same goes for acceleration. I just differentiate velocity in terms of time. Then repeating the same process, I will get the acceleration values over here.